Alright, let's look at this one. We have a change in displacement of 50, and the first stone was released at an initial velocity of 2.0. So, my final, let's use x equals x0 plus VIT plus 1/2 a, which would be gt squared since we're in the vertical world. My final position is 0 because it hits the water at 0. I start at 50 meters. My plus down is negative, so it'd be negative 2.0 meters per second times t. Plus this minus, remember gravity is minus, so this is going to turn into negative 4.9 meters per second squared. Well, that's negative, the whole thing's negative. T squared. This is a quadratic. When I go to my quadratic solver on Google, and I just Google one, it's going to turn into negative 4.9 meters per second squared t squared minus 2.0 meters per second t plus 50. When I put that in, I get t equals, let's see here, 3.0299 something seconds, which seems reasonable, and t equals negative 3.4 seconds, which is not reasonable. So, they both hit at the same time. So, after I hit, the total trip is 3 seconds. And it says, when does the second stone hit the water after the first one is released? The whole time is 3 seconds. Now, the time that the first one was in the air, or excuse me, the second one was in the air, would not be 3 seconds, the first one, but the entire trip was, so that's A, 3 seconds. Alright, so let's go to B. We know the first stone took 3 seconds to hit the ground. However, the second stone was thrown 1 second later. So the time for second stone in the air equals 2 seconds. And we want to know the initial speed of the second stone with time and distance of 50 meters. I'm going to have to throw it back into the equation with time in it. So x final equals x initial plus VI. Initials are now zeros, plus 1/2 GT squared. My final position was 0. My initial position was 50 meters. I don't know what my initial velocity was, but time was 2 seconds. And this is going to turn negative because gravity is negative. 0.5, 9.8 meters per second squared. 2 seconds, but I have to square it. So let's get an answer for that final part. 2 squared is 4 times 9.8 times 0.5. So I get 50 meters plus VI minus 19.6 meters. I'm going to have to subtract 50 from both sides and add 19.6 meters to both sides to get VO 2.0 seconds. So 50 minus 9.6 is negative 30.4 meters equals VO 2.0 seconds. Divide the seconds on both sides, put by, and VO would be divided by 2, 15.2. But it's negative. Negative just means down. I threw it down with an initial velocity of 15.5 meters per second, and negative would be down, and that seems to make sense. Alright, for part B. Alright, part C is speed of each stone as it hits the water. Let's do the first stone. And we know the initial velocity of the first stone, and we know time. So I am going to take this equation. Alright, let's get this final velocity. Initial velocity was negative 2. Negative 2.0 meters per second. And we know gravity's negative, so plus negative would be negative 9.8 meters per second squared. But it's times 3 seconds. We said a couple of slides ago that this thing was in the air for 3 seconds. So I'm going to get negative 2.0 meters per second minus 29.4 meters per second, which gives me 31.4 meters per second. But don't forget your negative. All that means is down. Alright, let's do the second stone. The second stone was only in the air for 2 seconds, so I'm going to go V equals VO plus AT. Its initial velocity was negative 15.5 meters per second. We did that for part B. Negative 9.8 meters per second squared, because it's going down and gravity's down. And this one was only in the air for 2 seconds because it was 3 seconds minus 1. So 9.8 times 2 would be negative 19.6 meters per second. And I still have my 15.5 meters per second. And you put those together, 19.6 and 15.5. I'm going to get 35, negative 35.1, yes, 0.1 meters per second. And the negative just means down, which makes sense. Woo-woo, woo-woo.